Validity and misconceptions are two words that are sort of linked together and that we'll use throughout the year as we move through different scientific concepts. For something to be valid or to have validity in the sciences means that the way that you went about figuring that thing out was well done and trustworthy. It's logical. It applies Occam's razor. You've taken into consideration all the things that you need to do in order to get to the right answer. A misconception is an idea that's wrong or just incomplete. And here's how the two words go together. This box that I asked you to write about in your black box debrief has some problems with it. I would say that these students have a misconception about how the box works. Now, it's a black box. We can't open it, so we can never really know exactly what the inside looks like. But this model of the box has some things about it that just are not valid. For example, the way that the funnel is designed in this picture doesn't make sense. It's not logical. It doesn't fit the observations that we saw in class. The funnel goes straight down to the middle tube, and there seems to be no way for the funnel to direct the flow of water. So this is an incomplete idea at best. There are other things that I found wrong with this picture, and I'm sure you did too. And there are some things that I think are good about the picture. But overall, its validity is questionable. When you're investigating a model and trying to decide or evaluate whether or not that model is valid or not, there are certain things that you have to consider, right? So here are the things that go into deciding whether or not a model is valid. You want to ask yourself, hey, does this model apply Occam's razor? That's number one. Number two, does this model, does it explain all the observations that we made? And does it predict future observations accurately? Which you won't know, of course, until the future comes. And those were the things that I asked you to consider in evaluating the validity of the model. There are other ways to consider the validity of other scientific ideas. For example, if you want to know if a hypothesis is valid or not, you're going to ask yourself whether or not it's logical and whether or not there is a rationale that's based on inferences rather than on assumptions. That's how you judge the validity of a hypothesis. Doesn't tell you whether the hypothesis is right or wrong. Hopefully, what will do that is an experiment. Experiments also can be considered in terms of whether or not an experiment is valid, if it's well done and trustworthy, if it's a fair test. And the things to consider for experiments are a little bit different. For example, when we tried to figure out whether or not we were running a fair test for this experiment with the dye in the water, there were a couple of things that I wanted you to consider. Number one would be, do you have a control and an experimental group? You always need to be able to compare your results to something. In this experiment, the control group and experimental group, doesn't matter which one you call which, but you are comparing hot to cold, so you do have a point of comparison. So that makes the experiment more valid. The fact that you have that control group there to compare your experimental group to helps to increase the likelihood that you're going to get the right answer. Keeping things constant other than the thing you were testing is also really important for considering something valid. When an experiment is run with multiple variables changing at once, it can confuse your results and make it impossible for you to know whether or not you have been successful in deciding whether or not temperature really affects dye color. So for example, if you change the type of container or the amount of dye or the color of the dye along with the temperature of the water, now we're not sure what's really causing the problem. Another thing that makes an experiment valid is multiple trials. If you don't repeat your experiment multiple times, it's hard to know whether or not you're getting the same result over and over again, and that's important. We trust results and think that results are more likely to be true if the results of an experiment are repeated multiple times. We call this getting precise data. Precise means close together. So if your numbers that you're getting for the time it takes something to happen are miles apart, if they're days apart, or hours apart, that's going to make you lose confidence in your results. However, if every time you do it, you're within a few seconds of each other, that's going to increase the likelihood, or it's going to increase your confidence that you are likely right. A poorly performed experiment that's not a fair test, that's not valid, can lead you to a misconception. You can believe something's true that isn't because you ran an experiment and you're thinking that you ran a good experiment when in fact you did not. So understanding how to evaluate the validity of things in science is really, really important. Every time we design an experiment, every time we make a hypothesis, anytime we construct a model or develop a theory, we want to be asking ourselves, is this model valid? And do we have any misconceptions caused by invalid models and theories and hypotheses and experiments? You'll find that you often also will have many misconceptions about things that you learned in the past because you probably have some invalid models in your mind. And we'll talk more about that in a new assignment called Misconceptions. See you in class.